your personal mail ID. ஓகேவா? பிரேக் டைமில் ஓகேவா டைமிங் பார்த்துக்கோ, கொஞ்சம் அட்டன் பண்ணு. Then you need to send a mail to the particular concern, and then only you will get a certificate. So please go through the message available in your placement group. Do follow the same. Okay. Any doubts after the class hour, please ask. Yes. With this, we will start the today's class. Today I am going with the full slideshow mode, so I can't access your chat box. So whoever want to interact, please unmute and talk. Okay. Yes. CAN protocol. Yesterday we have started and we discussed a few introduction about that CAN protocol. Whenever you find free time, go through the articles available in that CAN. Who invented this CAN bus protocol? Any idea, dear students? Who invented the CAN protocol?
Boss comments.
Robert Bosch. Very good, very good. Robert Bosch. So you people know about the name of the industry, Robert Bosch. They are famous for embedded based solutions. So even they, how many of them watched their washing machine? Robert Bosch washing machine, anyone? Or any relatives are working in that industry? Relatives are work பண்றாங்க ராபர்ட் பாஷ்ல. So if yes or no also, please browse about that particular company. Okay. If you are well versed in the basic C and little hardware things, you can attend off campus also. That kind of opportunities are available. So please explore your ideas. Definitely you will get. Go and browse in the website. They may conduct some contest also sometime. Please have a touch with those kind of industries all the time. Thereby we can update our knowledge, and also it will induce you to learn some new things. Okay. So Robert Bosch is a German-based industry, but fortunately we have many branches in our India. Yes, even it is available in Coimbatore. Coimbatore we have 2 branches, I think so. So your seniors are working there. Have a touch with the particular website and go through the requirements of the particular industry and prepare for it. Okay, yes. So Robert Bosch, they are well versed in their embedded system technologies. Nowadays they are focusing on the e-vehicle and autonomous vehicle. Okay, driverless cars they are trying a lot. Those people only introduced this CAN bus protocol to communicate between your various controllers present in your four-wheeler and the sensors and actuators and other devices present in your four-wheeler. Okay, so using this CAN protocol, as we discussed in the last class, you can interface these many systems are available in your four-wheeler. You can tie everything with a 2-wire. That is the beauty of this protocol. Even
Sir,
though you have,
present பண்றீங்களா sir?
sorry, screen is not visible. Okay, okay, present, sir. அப்போ எப்படி ஸ்ரீகரி கண்டுபிடிச்சு சொல்லிட்டான் தூக்கத்துல இருந்து. Is it visible, Srigari, right now?
Sir, இப்போ தெரியுது sir.
Just I opened the slide just now. So previous slide where you know it is a control area network. So even though we have dozens of sensors and actuators and display, many things are present in our four-wheeler. The advantage of this protocol, you can tie or you can connect these elements using only 2 wires. Okay. Anybody can tell what is the one more protocol uses 2 wire? Already we have studied on 2 wire protocol.
I2C.
I2C, very good. I2C. So I2C uses 2 wire. What is the purpose of the 2 wire? One is for In I2C,
Data.
one is for data, another one
Timer.
is for
Timer.
another one is for clock, another one is for clock. Okay, here we are going to use again two wire, but the purpose is little different that we will discuss in the consecutive slides. Okay, then explosion of electronic system. So electronic systems, நிறைய electronic systems இருக்கு. One beauty of the thing we need to highlight is everyone know the tire. Okay, so the tire is filled with air. But in your dashboard is the screen present in front of the driver. In the dashboard, you can check the current air pressure in your tires. So how you are getting the reading from your tire to the dashboard? Any idea? How you are measuring the tire pressure? Four-wheeler means you have four wheels. எப்படி சென்ஸ் பண்ணி அந்த ஏர் ப்ரெஷர் இங்க சென்ட் பண்றாங்க? Any idea? Any idea, dear students? See, actually, tire is a rotating object. Am I correct? If I fix any sensor over here, and taking wire from your tire to the dashboard, if your tire start rotates, what happened to this connecting wire? Any idea? ஒரு சென்சாரை கனெக்ட் பண்ணி இப்படி வயர் எடுத்துட்டு போய் இது கூட கனெக்ட் பண்றோம். அப்ப என்ன ஆகும்? Any idea?
Twist ஆகி
ட்விஸ்ட் ஆகி வயர் கட் ஆகும். அப்ப என்ன பண்ணணும்? இனி வாட் வி நீட் டு டூ? நான் சாட்ல எதுவும் போடாதடா, நான் ஃபுல் ஸ்கிரீன் வியூல இருக்கேன். அன்மியூட் பண்ணி சொன்னாலும் தெரியும். We need to remove this wire first of all. கரெக்டா? ஸோ அப்ப என்ன பண்ணலாம்? What type of technology we can adopt here?
wireless
communication.
Wireless I need to use. So I need to sense from here. Then I need to transmit it via any wireless technology. Then I need to receive in the dashboard. Then where I can fix the sensor? That is the second question. Are we using in the mouth of the tube? In the mouth la connect பண்ணிருக்கோமா sensors? It is not visible. Am I correct? But even though we are measuring, any idea where we have deployed our sensor? Any idea? Any idea? Sensor எங்க இருக்கு? இந்த மவுத்ல இல்ல. மவுத்ல இருக்க sensors also available, but most of them it is not fitted in the mouth. Then where it is? எங்க இருக்கு? ரோட்ல ஃபிக்ஸ் பண்ணிருப்பாங்களா? Are they fixed in the running road? No, it is not possible. Where எங்க ஃபிக்ஸ் ஆயிருக்கும்?
inside the tire.
Inside your tube. Inside your tube, you have a sensor. Okay, so that uses some technology called MEMS technology, micro electro mechanical system. Please note down this keyword. Micro electro mechanical system. Electrical and mechanical ரெண்டுமே put together use பண்ணி they are fabricating thousands of sensors. Okay, wow. These kind of MEMS sensors only we using in our mobile phones to check orientation of your mobile phone. Okay, and many and the accelerometers and different axis measure பண்றதுக்கு all thing we are using the MEMS sensors. Robert Bosch is also manufacturing some MEMS sensors. So go through this keyword. It's a powerful keyword. We buried the sensors inside the tube. So the tube learning the sense panni, it will transmit the signal. Okay, how wonderful the technology is. Okay, so likewise you have many things we need to discuss over here. As discussed in the last class, not only CAN is a single protocol used in the automobile industries. We have a few more things: LIN, FluxRay, and MOST. Okay, so media-oriented system transport. So these are all various protocols we use in automobile industries. Automobile industries means you don't think only the normal vehicle. we have a defense vehicles, defense. So defense, your vehicle you need to work in the extreme temperatures, extreme temperatures. Say example, minus 25 degree to plus, say example, not 100 or 80, 90 degrees Celsius sometimes, some extreme temperature range in a vehicle work. At the same time, the controller present in the vehicle as well as the sensor, everything properly need to communicate with my systems. So, எல்லாமே challenge தான் the particular vehicle, defense vehicle. So think about it, and also you think of the aircraft system. So aircraft system also the temperature varies wider range, and also here you need some sophisticated control, tolerance-free system you need to build. Else it will lead many accidents. So if you watch Discovery Channel, most of the time the failure or the air crash happen because of communication problem or some sensors or controller issues. Okay, so due to that we are facing many air crash. Okay, so these are all very, very important. Whenever you design a protocol and if you deploy in a particular system, you need to take care of the seriousness of the particular application. Okay, then we will get into the CAN in detail. As we discussed in the last class, it is a message-based protocol. It is a broadcast protocol. Broadcast means it will send the information to more than one device. But who will reply or who will receive means whoever wants that information, they will receive. Say example, engine speed if I am measuring, engine speed. So engine speed measure பண்றோம். So engine speed எடுத்து நம்ம யாருக்கெல்லாம் கொடுக்கலாம்? First and foremost thing, we will give it to the dashboard. Am I correct? Dashboard we will display the engine speed. Then we're using some accelerator system. So by controlling the accelerator, you are adjusting the engine speed. So the accelerator will give some input to the engine speed controller unit. The same unit may record what is the actual speed. Am I correct? So likewise, engine speed is a single parameter, but the parameter need to process in the different locations. Am I correct? So it is not advisable to send the information to the individual persons in a different time slot, because your four-wheeler has to do multiple tasks. You are sensing only the engine speed and you are sending the engine speed multiple times to the different processor means it is not advisable. Therefore, here they are using broadcast protocol. So engine speed will broadcast once. Whoever wants to have process the particular parameter, they will receive. Whoever means the controller. Okay, different controllers are available in your four-wheeler system. So எந்தெந்த கண்ட்ரோலெல்லாம் அதை வாங்கி ப்ராசஸ் பண்ணணுமோ அதெல்லாம் எடுத்து ப்ராசஸ் பண்ணிக்கும். ஓகேவா? ஐ ஹோப் திஸ் கீவேர்ட் இஸ் கிளியர் டு யுவர் பீப்புள். Am I correct? Broadcast. Am I correct, sir? இப்போ சன் டிவியில் ஒரு சேனல் டெலிகாஸ்ட் பண்ணுறாங்க. The Sun TV subscriber, say example, 2 lakh people இருக்காங்க. அவங்க ஒவ்வொருத்தவங்களுக்கும் சென்ட் பண்ணா it is not a feasible one. Am I correct? Therefore, they are broadcasting their channel. Whoever receiving, whoever subscribed, not going to watch. Whoever selected the particular channel at the time, they only watch. Am I correct, sir? Am I correct? I hope you clear about this keyword called broadcast. Okay? Am I clear? Yes. Now, you have a message identifier that we will come later. Then you have a 2 format. One is the standard CAN format, one another is the extended. Then speed, 1000 kilobits per second, 500 kilobits per second, then 100 kilobits per second. Different speeds are available. Then the node transmitting the message also listens. This is a fantastic feature available in the CAN. If node sends something, node means, say example, again you consider your engine speed sensor. Okay, the sensor sends the information means once it sends via the CAN bus, it also listen. What for I need to listen? See, whenever we are speaking something, uh, simultaneously we will sense. Am I correct? Sense point irukkum. Thappa soitomna we will interrupt. We will ask some apology like sorry or something. Then we will correct our words. Am I correct? The same way, that in the canvas, once the nodes start transmit, it also listens. Whatever the information sent via the bus, is it the same or not? It will listen. Okay, that is the keyword here. Transmitting message also listens. Okay, ஏன்னா நான் கனெக்ட் ஆயிருக்கேனாடா இந்த நோட்ல இருந்து ஒரு பெரிய பிரச்சனை. ஸ்கிரீன் விசிபிளா இருக்கு,
Yes, sir. Yes,
நான்
sir.
பேசுறது உங்களுக்கு ஃப்ளோ கரெக்ட். Yes, okay. Then, message may record by more than one controller. So, the same example you can take, the engine speed may received by more than one controller to process. Then, which node configured to receive the particular message will receive it? Yes, of course. Yes, of course. So, I have a CAN bus. We have connected many systems in the CAN bus, but all the controller or all the node may not record the engine speed. Am I correct? So whoever record the engine speed alone, they will take. Remaining nodes will ignore. They won't process. Okay? They won't listen for the particular information available in the campus. So that is the keyword here. Then message transmitted in the frame format. What is that frame format? Yesterday we gave some assignment to people to read a different frame format available in your USB protocol. So frame format is, it's very simple. You have a data. Before that you may have a start condition. Then you may have some parity. Then you have a stop. Likewise, your data is not a data alone. It has some frame format. So while you want to send the data, along the data, you will send some additional information. Therefore, it is called as a frame format. Okay, so the frame format is different for individual protocols. Each and every protocol follows the unique frame format. Okay, then 4 different types of frame formats available. One is the basic format, then the error, then the remote, and over. Note down, we will discuss these 4. Not 4, we will discuss 3. Okay, three. That is your basic frame, error, and remote in this contest. Okay. I hope this screen information is clear to everyone. With this, we will enter into a graphical representation. X-axis is your length of your canvas in meters and the bit rate. Okay, so in here we have discussed some speed, no, 1000 kilobits per second, 500 kilobits per second, 100 kilobits per second. The speed is related, highly related to your length of your bus. So if you take a length, say example 40 meter abdina, you can go up to 1000. Okay? No doubt in that. But if you are increasing the length further, say example 1000 meter, here your baud rate is limited. Even though it shows around 100 to 50, it is highly recommended to use 50 kbps. Okay, that means what? The distance increases means the baud rate will get decreased. So shorter the distance, higher the baud rate. Okay, so this is the typical the bit rate versus the bus length for the CAN bus protocol. This is for CAN bus protocol. It is not a generalistic graphical representation. Please take a screenshot of this one. Then the next information about the protocol is, sir, you said you have different levels of speed. Can we categorize the speed based on the application? Yes. Here the CAN bus high speed application is the example. Drivetrain. What is drivetrain? We will come to later. Okay, then low speed requirements called convenience. Convenience-na car-la நம்ம convenient-காக எதை யூஸ் பண்றோம்? Convenient-க்கு ஒரு mirror adjust பண்ணலாம், or ஒரு air conditioner temperature vary பண்ணலாம், or ஒரு the perfume-ஓட the injection level vary பண்றோம். Am I correct? So those are all called convenience-காக யூஸ் பண்றோம். Okay-வா? Infotainment. What is infotainment? Any idea? What is infotainment? What is infotainment, sir?
Sir, FM.
What?
Sir, FM.
Entertainment related activities, your media player, okay, and so on. Okay, so nowadays we were having some LCD TVs also in that four-wheelers. Am I correct? But it's not recommended to watch this things by the driver. Driver watch பண்ணாத மாதிரி பேக் சைடில் தான் ஃபிக்ஸ் பண்ணியிருக்கணும். Passengers can watch. Driver வாட்ச் பண்ணா அப்புறம் அந்த படம் தான் கடைசி படமா இருக்கும். சரியா? So likewise you have many things. அப்ப based on the application you can choose the speed of your canvas. எதுக்கு எதை யூஸ் பண்றது? ஸோ இங்க ஹை ஸ்பீடு கொடுத்துருக்காங்க பாரு. ஹை ஸ்பீடுக்கு இன்ஜின் டெம்பரேச்சர் மெஷர் பண்ணலாம், இன்ஜின் ஸ்பீடை மெஷர் பண்ணலாம். பிரேக், ஆப்வியஸ்லி பிரேக் எப்படி இருக்கணும்? பிரேக் சிஸ்டம் எப்படி இருக்கணும்? கம்யூனிகேஷன் ஃபாஸ்டா இருக்கணும். கியர் பாக்ஸ், ஓகே. தென் இது கூட வேற ஆக்சுவலி ஏர் பேக் வந்து லோ ஸ்பீட்ல இருக்குது. லிட்டில் கான்ட்ரவர்சி இன் திஸ். எதனால அது லோ ஸ்பீட்ல இருக்குன்னு தெரியல. தென் சென்ட்ரல் லாக்கிங் சிஸ்டம். Central locking system, anybody knows what is central locking system? முன்ன மாதிரி இல்ல, கார்ல ஏறி உட்காந்தோன்னே டிரைவர் டோர் லாக் பண்ணி எல்லாம் கேட்க மாட்டார். என்ன பண்ணுவார் டிரைவர் have one master control nearby the door. Am I correct? அந்த ஒரு பட்டனை கிளிக் பண்ணார் அப்படின்னா entire door will get locked. Am I correct, sir? Then air conditioner, lighting. So இது மாதிரி நம்மளோட application critical define பண்ணி you can choose the can-ஓட என்ன ஸ்பீட்ல அதை ஆப்ரேட் பண்ணுன்றதை you can decide. Okay, sir? இதுக்கு என்ன யூஸ் பண்றாங்கன்னா again they are using the copper wire to communicate. It is a wire protocol. Wire யூஸ் பண்ணி தான் communicate பண்றோம். You can go up to 1000, but most of the time we are going with the 500 kilobits per second. So these are some takeaway points from this slide. This point I will clarify to you later. Okay, airbag actually has to come in high speed, but here low speed la irukku paathu solren. Okay va? Is it clear? These points are clear to everyone? Whoever listening, they can understand. Others are requested to listen. Okay, that's all we can do in the online mode. We can't monitor everyone. Okay, yes. Here they gave some one example. Various control unit என்னெல்லாம் நம்மகிட்ட இருக்குன்னா engine control unit, then ABS system. ABS அப்படின்னா என்ன சார்? ஆன்டி லாக் பிரேக்கிங் சிஸ்டம். ஓகே, அப்படின்னா என்ன? ஒரு பவர்ஃபுல் டெக்னிக். அது என்னன்னு கொஞ்சம் அப்சர்வ் பண்ணி படி. Then you have a dashboard. So these three things are tied with canvas. அதுதான் இங்க சொல்ல வராங்க. These three systems are tied with the canvas. So அப்ப பார்த்துட்டா the individual systems will connect with the number of sensors. This blue color line you may use any type of protocol or any type of communication system. Okay, but together linking with these three systems must be a CAN. அதான் இங்க ஹைலைட் பண்றாங்க. The blue color lines you may use different type of peripheral interfacing technique. Okay, but between the controller or the nodes you need to use the CAN protocol. So that is the idea. They are using this one in our four-wheeler. Okay, then what is the purpose of interconnecting these three? What is the purpose of interconnecting these three? This will interchange the data. It will interchange the data. So in the engine speed, okay, தென் இங்கே நம்ம இன்ஜினுக்கு ஏதாவது ஒரு கமாண்ட் கொடுத்தா அதை அப்படியே ஆன்டி லாக் பிரேக்கிங் சிஸ்டத்தில் சென்ஸ் பண்ணலாம். ஸோ ஆன்டி லாக்ல ஏதாவது ப்ராப்ளம் இருக்கு அப்படின்னு சொன்னால் இது இங்கிருந்து எங்கே கொடுக்கலாம், இன்ஜின் கண்ட்ரோலருக்கு சம் கமாண்ட் கொடுக்கலாம். ஸோ bidirectional communication is always possible here. Okay, yes. Then all information exchanged between your controller unit along maximum of 2 wires. These 2 wires in general called as a CAN data bus. So இந்த 2 wire என்னன்னு சொல்றாங்க, CAN data bus அப்படின்றாங்க. ஓகேவா? இதுல என்னென்ன இன்ஃபர்மேஷன்ஸ் எல்லாம் சென்ட் பண்றாங்க அப்படின்னு பார்த்தோம்னா enormous information. It is these things for even for your diesel engine and petrol engine, fuel engines, they are transmitting many informations. Then you think about your e-vehicle and autonomous vehicle. Autonomous vehicle allam, they are telling that in and around your vehicle you have plenty of sensors in autonomous vehicle. அப்ப think பண்ணி பாரு இவ்ளோ information every seconds க்கு நம்ம transmit பண்ணுவோம் அப்படின்னு. இங்க ஒரு சின்ன எக்ஸாம்பிளுக்கு தேவை ஒரு இன்ஜின் கண்ட்ரோல் வந்து என்னெல்லாம் கொடுக்குறாங்க பாரு, இன்ஜின் ஸ்பீட், ஃபியூவல் கன்சப்ஷன், த்ராட்டல் வால்வ் பொசிஷன். த்ராட்டல் வால்வ்னா தெரியுது, அந்த வால்வ் அட்ஜஸ்ட் பண்றதை டிபெண்ட் பண்ணி தான் நம்மளோட ஃபியூவல் எவ்வளவு நம்ம இன்ஜெக்ட் பண்றோன்றத பண்றோம். ஓகேவா? ஸோ இதெல்லாம் எடுத்து எங்க கொடுக்குறாங்கன்னா ஆட்டோமேட்டிக் கியர் பாக்ஸ் கண்ட்ரோல் யூனிட்டுக்கு இதெல்லாம் இன்ஃபர்மேஷன் இங்கிருந்து இங்கே வருது. Then the automatic gear control unit giving some information about engine intervention and upshift and downshift of the gear. So இங்க என்ன கியர் இங்க செலக்ட் ஆயிருக்குன்றத the engine control unit ஒரு இன்ஃபர்மேஷனை கொடுக்குது. So likewise we are exchanging large volume of information. We are exchanging large volume of information in our four-wheelers. Okay, so this bus going to carry bulk of informations. Okay, and also different intervals it will pass its information. So one example, the engine control unit and the automatic gearbox. Likewise, you can correlate with any other control unit and any two control units, and you can think about the parameters what it will transmit between these two. Okay, if I tell you one thing, seat belt, the seat belt, you have one controller. Anyone can tell what are all the information it will transmit. Seat belt ஒரு கண்ட்ரோலர் இருக்கும், அந்த கண்ட்ரோலர் என்ன டிரான்ஸ்மிட் பண்ணும்? எனி ஐடியா? என்ன மாதிரி இன்ஃபர்மேஷன்ஸ் சென்ட் பண்ணும் கண்ட்ரோலர்? எனி ஐடியா? ஹலோ, சீட் பெல்ட் சேஃப்டி சிஸ்டம்க்கு ஒரு கண்ட்ரோலர் இருக்கு, அந்த கண்ட்ரோலர் என்னென்ன இன்ஃபர்மேஷன்ஸ் எல்லாம் நமக்கு டிரான்ஸ்மிட் பண்ணும்? ஹலோ ஹலோ
seat belt போட்டோம்னா airbag open ஆகும்.
No. That I'm asking what kind of information the controller will send. The seat belt safety system controller. என்னெல்லாம் இன்ஃபர்மேஷன் கொடுக்கும்? ரொம்ப சிம்பிளா whether the seat belt வந்து ப்ராப்பரா ஃபிக்ஸ் ஆயிருக்கா இல்லையா. Am I correct?
Yes sir.
Beyond that, anything it has to send, seat belt where send panma. Seat belt also, that particular controller also sends one thing, whether the person is present or not. Either check பண்ணிட்டு தான் it will bother about the seat belt. இங்க யாருமே இல்ல, அப்ப seat belt போடு கத்து, it is meaningless. Am I correct? So first it will check whether the persons are present or not. If the person is present and the vehicle is in moving, okay, at the time it will give alarm. So like that it will sense many parameters and it will work for that. Okay, now we will come to the transceiver portion available in our campus. It's a very important block available in the transceiver. You are not watched the full canvas arrangement. நாங்க அந்த அரேஞ்ச்மெண்ட்டே பார்க்கல சார், உங்களுக்கு இது அண்டர்ஸ்டாண்ட் ஆகலாது அப்படின்னா let me show the arrangement to people first. So this is the arrangement. Each unit has some block. So on the block என்ன இருக்குன்னா you have a setup like this. The particular control unit, then you have some flag arrangements, some mailbox, then you have a last one as a transceiver. So now we are going to discuss about this transceiver. The transceiver NSR pannu. You people know, my controllers are always capable of sending the information in TTL logic. But my particular bus system is going to work in a different thing called a CAN bus. So CAN bus like voltage level different. So when the transceiver NSR pannu அப்படின்னா it will convert the particular logic level. So logic level convert பண்ணி proper connect பண்றதுக்காக we are going to use the transceiver. We will discuss about the transceiver. So transceiver குள்ள என்ன சார் இருக்கு? So transceiver is the one, it does two actions. Transceiver has a transmitter and receiver amplifier. So ரெண்டு இருக்கு. Transmitter and receiver amplifier இதுக்குள்ள இருக்கு. Okay, it converts your serial bit stream logic to an CAN module electric voltage. CAN module oda voltage level kaga அதை convert பண்ணி கொடுக்கும் and vice versa. What it means vice versa? If your controller wants to transmit your information, it will convert that logic level into a CAN level and it will transmit. Similarly, if you receive some information, that information is again converted into a logic to CAN to logic. So that's why it is called as a vice versa. So in the conversion process will happen here. So the whole arrangement is simply given with the one circuit diagram. So circuit diagram consists of one pull-up resistor, then one switch. Pull-up resistor, one switch. Then in between the connection, you have a common point. From the common point, we are taking to our bus. Okay, so this is our CAN bus. So this is your actual logic level, what you are receiving from your system. Okay, so இது எப்படி கன்வெர்ட் பண்ணி நம்ம லாஜிக்கல் லெவல்ல கன்வெர்ட் பண்ணி சென்ட் பண்றோம். Okay, it uses transmitter and receiver unit. How it is going to perform, we will see. Before that, your transmitter block is connected via the switching arrangement. The receiver is directly connected via this receiver amplifier. So that is the point they have quoted here. This array while you transmit, it is passed via this amplifier unit. Once you receive, it is passed via this amplifier without this pull-up and switching arrangements. Okay. Yes. Now we will get into this concept in detailed way. Slides so that it will be good. Okay. Let me go by one line. Okay. Yes. Now, here you may see three transceivers are connected in a bus. Okay. The first switch is in open condition. Second switch is in open condition. The third switch in closed condition. Okay. If the switch is closed, the circuit diagram is arranged in such a way that if any one switch is closed, your bus will receive logic low. Please note it down. If any one switch is closed, your bus will be in logic 0. Irrespective of position of the other transceivers. ஏதாவது ஒரு transceiverல க்ளோஸ் ஆயிருந்தாலே என்ன ஆயிரும்? பஸ் வந்து லாஜிக் 0 போயிடும். ஓகே, ஸோ 3 transceivers இருக்கு, பஸ் 0 போயிருக்கு. ஸோ அந்த பஸ் 0 போகணும் அப்படின்னா the condition is that any one should be in closed condition. If my bus want to be in a logic high, all the transceivers should be in off position. I hope this is clear to everyone. The switch position and its corresponding logic level available in the CAN bus. Okay, so here two different states are available. First one is the state 1. It's called as the inhibited state. Please note down these keywords, important. Inhibited state, that is a switch open. Switch open. So these two are state 1. State 1. This is in a inhibited state. Okay. Then your bus level will be in logic 1. If you are considering single transceiver connected in the bus and your switch is in open condition, your bus will receive logic high. That is level high. Okay. State 0, my switch is in closed condition. If my switch is in closed condition, my bus will be in logic low state. Please note down this change in logic levels. If my switch is in closed condition, my bus will in logic low state. Okay. So according to the switch position, we are going to transmit the information via the CAN bus. Okay. Logic 1 transmit pannuma, 0 transmit pannumaன்றத based on this switch position we are going to design. Okay. Yes. Now, if the switch is in a closed condition, it is called as a active state. Can I please note down the keyword? Very important. Active. If my switch is in open condition, it is said to be passive. Passive அப்படின்னா switch openல இருக்கும். That means நம்ம பஸ்ல logic 1. Okay. Active அப்படின்னா switch closedல இருக்கும். பஸ்ல value logic 0. Is it clear up to this? What is active and passive? Active means switch close, busla logic 0. Passive means switch open. In your bus you have a logic 1. Is it clear up to this? I hope it is clear to everyone. Then here you have another name for this active and passive status. Please note down that. For your passive level, it's also called as a recessive state. Your active level is also called as a dominant. What for it is dominant? Listen. If your system is in active, that is your switch is in closed condition. This is the dominant one. In the logic irukko adha dominant busla irukku. Am I correct? Switch வந்து closed இருந்துச்சு, ஏதாவது ஒரு switch closed இருந்துச்சுன்னா that will dominate the bus. Therefore your logic 0 in the CAN bus is called as a dominant state. Please note down. Recessive state means if your bus is in logic 1, that is called as a recessive. ஆனா கொஞ்சம் கன்ஃபியூஸ் ஆகக்கூடாது, கொஞ்சம் ஒரு போர்வை எழுதிக்கோ. State 1, switch open. The switch open is said to be a passive state. The passive state is also called as a recessive. Is it clear? The chain link? State 1, switch open, said to be passive. It is also called as a recessive. What is the opposite to that of this? State 0, switch close, active, that is also called as dominant. Is it clear, sir? Don't get confused with this two different terms. Most of the time we will use recessive and dominant. Hereafter we will most of the time. Yes.
Sir, switch close ஆனா எப்படி சார் லாஜிக் 0 இருக்கும் பஸ்ல?
இங்க பாருங்க, நீங்க கனெக்ஷனை பாருங்க. இந்த சுவிட்ச் க்ளோஸ் ஆயிடுச்சு. அப்ப இங்க இருந்து லாஜிக் லோ இப்படி கனெக்ட் ஆகுது. Here logic high is connected via some value of resistor. எது டாமினண்டா இருக்கும்? லாஜிக் ஹை டாமினண்டா இருக்குமா, லோ டாமினண்டா இருக்குமா? As per this particular node is concerned.
0
0. இப்ப இந்த பஸ் 0 ஆயிடுச்சு அப்படின்னா the entire bus wire will get 0. அப்ப in the previous things we have to we quoted one wonderful point. The transmit as well as it listen. Transmit point listen பண்ணு. Here you have a 3 transceivers. This transceiver will send some information and it will listen the bus. Okay, நம்ம 0 send பண்ண சொன்னா இங்க 0 இருக்கு. This transceiver will be happy. But these two transceiver will not happy. Why? These two transceivers plan to send the information as a logic 1. But once it's listened, it will listen as a 0. அப்ப என்ன அர்த்தம்? These two transceivers need to keep quiet for some time. Because one more transceiver taken the bus for communication. That we will discuss in the last contest. Okay, that arbitration discuss பண்ணும்போது we will discuss this point in clear. Okay, so இங்கிருந்து நம்ம என்ன டேக்அவே எடுத்துக்கிறோம்? ஸ்டேட் 1 என்ன, 0 என்ன, டாமினன்ட்னா என்ன, ரெசிசிவ்னா என்ன, இந்த ரெண்டு கீவேர்ட் ரொம்ப இம்பார்ட்டன்ட். ஓகே, as we discussed earlier, CAN uses two-wire protocol. What is the name of that? CAN high, CAN low. CAN high, CAN low. CAN hyphen capital H கூட மார்க் பண்ணிருப்பாங்க. Similarly, CAN hyphen capital L. That means what? CAN high and CAN low. Okay, sir? Okay. It uses twisted pair cable. Twisted pair cable. Here we are using twisted pair cable. So CAN high and CAN wire, low wire. So the wire like என்ன type, என்ன மாதிரி informations நம்ம transmit பண்ண போறோம். So here we are going to transmit differential signal. Here we are going to transmit differential signal. So the differential signal எப்படி இருக்கும் ரெண்டு இதுலயும்? This is a typical waveform of your voltage level. The pattern in which we are going to transmit the CAN voltage level. Okay, so you know that what is the recessive state and dominant state. Resistive state and dominant state. Okay, so whenever your system is in recessive state, your two wires will have the voltage level of 2.5 volt. 2.5 volt. I hope these two color difference you may understand. What is yellow color represents, sir? What is yellow color represents? CAN high wire. Green wire represents CAN low wire. Please observe the voltage level. Please observe the voltage level. Where CAN high and CAN low both are in the voltage level of 2.5 volt. 2.5 volt. 2.5 volt. Okay. Then this is during recessive state, or during resistive state, these two wires will be in the same logic level, that is 2.5 volt. This is also called as a rest state. It's also called as a rest state. Okay. Then what is the dominant state logic level? During dominant state logic level, your CAN high wire have the logic level of voltage level of 3.5 volt. Your CAN low wire having the voltage level of 1.5. Then what is the difference between these two wire? What is the difference between these two wire? 3.5 minus 1.5. How much it is? What is the difference between difference of 3.5 and 1.5? 2 volt. So 2 volt is the voltage difference between your CAN high and CAN low during dominant state. Please note down this waveform. Very important. So this is your recessive state. R nu potuko. This is your dominant state. D in potuko. Okay, is it clear? So what is the duration? எவ்வளோ இருக்கும்? 2 microseconds. 2 microseconds. 2 microseconds is the duration of the particular dominant state. இவ்வளோ seconds இது இந்த லாஜிக்ல இருந்தா போதும். Your system will understand that is my dominant bit. This is my recessive bit. So recessive bit may prolong for long time. Restல வந்து continuous-ஆ கூட இருக்கலாம். Okay. Is it clear, sir? Is it clear? Is it clear? Dominant voltage level and recessive voltage levels. So the yellow and green color wires are CAN high and CAN low wires. CAN high and CAN low wires. அதில் என்ன voltage நம்ம சென்ட் பண்றோம். ஆனால் the differential signal அப்படின்னாலே you need to remember your operation amplifier. So inverting, non-inverting and inverting இதில் ஒரு voltage சென்ட் பண்ணுவோம். So V1 minus V2. இதில் என்ன டிஃபரன்ஸ் இருக்கோ அந்த டிஃபரன்ஸை தான் உங்களோட ஆம்பிளிஃபையர் ஆம்பிளிஃபை பண்ணி கொடுக்கும். Am I correct? So இந்த இன்புட்ல நம்ம என்ன சிக்னல் கொடுக்குறோம்? This is your differential signal. Okay? Yes. Now நம்ம என்ன வோல்டேஜ் லெவலில் டிரான்ஸ்மிட் பண்றோம்? இந்த டிரான்சிவர் நம்மளுக்கு என்ன லாஜிக்கா சேஞ்ச் பண்ணி தருது. So here we are using some TTL logic 0 to 5 volt. Dominant அப்படின்னு பார்த்தா TTL பொறுத்தளவுக்கு லாஜிக் 0. TTL பொறுத்தளவுக்கு லாஜிக் 0. பட் CAN பொறுத்தளவுக்கு CAN high will be in என்ன வோல்டேஜ் 3.5ல இருக்கும். CAN low will be in 1.5 volt. The difference between these two is 2 volt. This is CAN level. This is your logic, TTL logic level. Don't get confused with this. That what is the purpose of the transceiver? It will convert the voltage level from your TTL to CAN and also CAN to TTL, vice versa. இப்படி இருந்து இப்படி கன்வெர்ட் பண்ணும், இப்படி இருந்து இப்படி கன்வெர்ட் பண்ணும். So let me finish the important point. இங்க dominant அப்படின்னா TTL ல 0, but இங்க CAN ல பாரு 2 volt. Similarly, the recessive level here it is 5 volt, logic high, okay, but here it is 0. CAN light is 0 volt, okay, and so on and so on. Again இங்க என்ன இருக்கு? dominant என்ன இருக்கணும்? ரெண்டு வயரும் 2 different logicல இருக்கணும். So please note down this diagram. Don't get confused with the TTL level and the CAN level. Okay, is it clear, sir? Is it this image is clear to everyone? This image speaks about the voltage levels in your TTL and your CAN level, and also it gives the function of your transceiver. It will do the level translation action. Is
Sir.
it clear, sir? Solunga, sir.
Sir, CAN high, CAN low அந்த பஸ் பைடைரக்ஷனலா சார்?
ஆமா, CAN high, CAN low bidirectional தான்.
சார் அது ஏன் சார் பைடைரக்ஷன்?
ஏன் bidirectional? கண்ணு இங்க பாரு, this is my controller. I am using 2 wire. Okay, 2 wire. Here I have connected ஒரு இன்னொரு கண்ட்ரோலர். ரெண்டு கண்ட்ரோலர் இருக்குன்னு வச்சுக்கோங்க. இந்த கண்ட்ரோலர்ல இருந்து இந்த இன்ஃபர்மேஷன் இந்த கண்ட்ரோலருக்கு வரலாம். At the same time இந்த கண்ட்ரோலர்ல இருந்து some information இங்க போகலாம். Am I clear, Srihari?
சார் அந்த டிரான்சீவர் பர்பஸ் எதுக்கு சார் TTL ல இருந்து CAN அது?
See this particular controller kana நம்ம கண்ட்ரோலர்ல என்ன பண்ணுவோம்? LPC 2148 தான் படிப்போம். இந்த LPC 2148 லாஜிக் லெவல் என்னது? 3.3 வோல்ட் CMOS வோல்டேஜ் லெவல் தான் அது ஆபரேட் ஆகுது. கரெக்ட்டா? பட் இந்த வயர்ல போகும்போது அந்த லாஜிக் ஒர்க் அவுட் ஆகாது. கரெக்ட்டா? கரெக்ட்டா?
சார்
ஆனா வெரி சிம்பிள். RS 232 நம்ம படிச்சோம். RS 232ல RS 232ல பாத்தீங்கன்னா +12 வோல்ட் and -12 வோல்ட் நமக்கு வேணும் கம்யூனிகேட் பண்ணும்போது. அப்ப அங்க ஒரு லெவல் டிரான்ஸ்லேட்டர் யூஸ் பண்ணோம். வாட் இஸ் த நேம் ஆஃப் தட் IC? Max 232 IC யூஸ் பண்ணோம். அதே மாதிரி தான் இங்க transceiver is going to do the level translation work. Is it clear? Is it clear? Okay.
Yes, sir.
Now we will see. See, I want to transmit my engine speed as a 1800 RPM. அப்ப என்ன ஆகும்னா ஃபர்ஸ்ட் இந்த RPM வேல்யூ பைனரியா மாத்துவாங்க. ஸோ அந்த மாத்தின பைனரியை எகெயின் ஐ நீட் டு கன்வெர்ட் இன்டு எ கேன் லெவல். அப்புறம் தான் அந்த ஒயர் வழியா டிரான்ஸ்மிட் பண்ண முடியும். Then again, if my system receives the information, can level இருக்கிறத you will convert it into the binary value. Then only you can process. Am I correct? Am I correct? So engine speed first converted into a binary value. Then it is passed via transceiver. Then transceiver converts the level and it sends it to the bus. Then again, via bus, we will receive the information. Then we will convert the information into a binary pattern. Okay, this binary pattern will give you information about your engine speed. So engine speed, இங்கிருந்து இங்க send பண்ற அப்படின்னா you need to do these actions. Okay, first your engine speed information into a binary pattern. The binary pattern converted into a can level using transceiver. Then in the receiver side, you need to again convert your can level into a binary pattern, then you need to process. This is called as an information exchange. Like that, you are transmitting many informations, not only the engine speed, you will transmit many parameters using this CAN bus. Okay? Okay? Yes. Then where in sir? எதுக்காக இந்த differential signal use பண்றோம்? In the last class itself I told, whenever we are discussing CAN bus protocol, time முடிஞ்சிருச்சா? Okay, we will wind up the session. In tomorrow's class we will discuss what we will discuss. Let me show in the message இன்னும் கொஞ்சம் டீடைலா எப்படி டிரான்ஸ்மிட் பண்றோம்ன்றத பார்க்கலாம். Then frame format, then arbitration. அவ்வளவுதான். இது பார்த்துட்டோம் அப்படின்னா CAN bus protocol முடிஞ்சிடும். I hope next class we can cover this portion. Okay. So thank you very much for your patient listening. Bye. Any doubt so far? Doubt வரணும்னா கொஞ்சம் போய் ப்ரௌஸ் பண்ணி பாரு இந்த ப்ரோட்டோகாலை. ரொம்ப நிறைய அப்ளிகேஷன் ஓரியன்ட் இது. இதை படிச்சு பாரு. ஏதாவது டவுட் இருந்ததுன்னா நெக்ஸ்ட் கிளாஸ்ல வந்து கேளு. ஓகேவா? We stop recording the session.